Problem 46 reviews parametric equations. So in a parametric equation, we have t as an extra variable, and we use t to find x and y. So we're going to take t and plug it into x equals t plus 5 to find our x values. So if I plug in a -2, I get a 3. If I plug in a -1, I have a 4. If I plug in a 0, I have 5. If I plug in 1, I have 6. And if I plug in 2, I have 7. Now we're going to take those same t values and plug them in for y. So if I plug in a -2, I have -3 squared, which is 9. If I plug in a -1, I have -2 squared, which is 4. If I plug in a 0, I have -1 squared, which is 1. If I plug in a 6, if I plug in a 1, I have 0 squared, which is 0. And if I plug in a 2, I have 1 squared, which is 1. So now we're going to graph our x and y values, just like you would normally graph x, y coordinates. So we have a point at 3, 9. We have a point at 4, 4. 5, 1. 6, 0. And then 7, 1. So it looks like what this is doing is it is going to come down and turn around and come back up. And so we want to show the orientation of that. So when t equals -2, this is the point when t equals -1. So our arrows are following in this direction. So now we need to eliminate the parameter and write our rectangular equation that just includes x and y. So to do that, what we're going to do is we're going to solve for t in terms of x. So I'm going to subtract 5 from each side, so I have x minus 5 equals t. And now I'm going to take that value and plug it in for the t in the y equation. So I have y equals x minus 5 minus 1 squared, which is x minus 6 squared. Now we need to state any restrictions. There are no restrictions for t, so t is in between -infinity and infinity. We can plug in anything we want for t. There are also no restrictions on our x values. We can plug in anything we'd like to for x, and x will become anything because we just have t plus 5. So x is also in between -infinity and infinity. There are some restrictions for y. As you see, all the y values are positive because we come down to 0 and we turn back around. So y is greater than or equal to 0. Now we will review converting polar equations to rectangular form. So we're taking a polar equation and writing it so there's x and y's in the equation instead. So we have r equals 3 cosine theta. So we want to remember that x equals r cosine theta. And we see that we have a cosine theta in our equation, so we're going to divide by r. So we know that x over r equals cosine theta. And that's what I'm going to substitute in for cosine theta. So I have r equals 3 times x over r. Now I'm going to multiply both sides by r. So I have r squared equals 3x. If you remember from our polar equations, r squared equals x squared plus y squared. So we have x squared plus y squared equals 3x. If you want to, we can set the equation equal to 0. So our final answer is x squared plus y squared minus 3x equals 0. But you can see it in two ways. For number 6, we have the equation r equals 6. We know that x squared plus y squared equals r squared. So what we can do is take r equals 6, and we can take 6 and plug it in for r. So we have x squared plus y squared equals 6 squared. So x squared plus y squared equals 36. And that is an equation of a circle, so that's a perfectly good rectangular equation. For problem 48, we're going to use the equation r equals 4 sine 3 theta and graph that. I forgot to give you an equation in the original problem. So the first thing we want to do is find the theta values that give us the maximum of r. And the maximum of r is going to be 4, since it is on the outside. To find the theta values that give us the maximum, we need to take sine 3 theta and set it equal to 1 and to negative 1. Sine equals 1 and negative 1 at pi over 2 and 3 pi over 2. But we need to write this in general form before we divide by 3. So we have 3 theta equals pi over 2 plus pi n. Now we're ready to divide by 3. So the thetas that will give us the maximum are going to be pi over 6 plus pi n over 3, and we need to list them out. So our first one will be pi over 6, and then if we add pi over 3 or 2 pi over 6 to it, we will get 3 pi over 6, which is pi over 2. If we add 2 pi to 3 pi, we get 5 pi over 6. And then 7 pi over 6. And then we will get 9 pi over 6, which is 3 pi over 2. And then 11 pi over 6. So those are our theta values that give us the maximum of r. So now what we need to do is we need to take those theta values and plug them in order to graph. If you look at the polar graphing sheet, we know that this is going to be a rose curve with 3 petals. So really we only need to plug in 3 of these values to find our 3 petals. So we'll plug in the first 3. So we will have a petal at pi over 6, at pi over 2, and at 5 pi over 6. We'll put the other maxes and mins on just in case we end up having to go backwards. So if I plug in pi over 6 to 4 sine 3 theta, I have 4 times the sine of pi over 2. The sine of pi over 2 is 1, and 4 times 1 is 4. So I have a polar coordinate at 4 comma pi over 6. So that is one of our petals. Then we can plug in pi over 2. So we have 4 times the sine of 3 times pi over 2. So that would be 4 times the sine of 3 pi over 2. The sine of 3 pi over 2 is negative 1, and negative 1 times 4 is negative 4. So we have a polar coordinate at negative 4 comma pi over 2. So if I go to pi over 2, because I have a negative 4, I need to go backwards 4. So there is my second petal. And finally, we'll plug in 5 pi over 6. So we have 4 times the sine of 3 times 5 pi over 6, which is the same as 4 times the sine of 5 pi over 2. 5 pi over 2 is the same as pi over 2. So the sine of pi over 2 is 1, and 4 times 1 is 4. So we have our third polar coordinate at 4, comma, 5 pi over 6. And so that is our rose curve with 3 petals.